Hello everyone, today's topic is speed, distance and time. This is one of the most important topic from General Aptitude, and in today's video I am going to discuss some really fast tips and tricks to solve some questions from this topic. So before using these tricks, it's really important for us to know the basic formulas of this chapter. So some basic formulas from this chapter are speed equals to distance by time. That can also be represented by d by t, and the average speed is given by total distance by total time. And for the conversion of speed from kilometer per hour to meter per second, we will multiply the speed by 5 by 18, and for the conversion of speed from meter per second to kilometer per hour, we will multiply the speed by 18 by 5. Okay, so let us see how to convert kilometer per hour to meter per second. 1 kilometer per hour, this can be written as 1 kilometer by hour. Alright, now which is equals to 1000 meter, and 1 hour is equals to 3600 seconds. Alright, now on cancelling, we will get this as 5 by 18. So this is how we get 1 kilometer per hour is equals to 5 by 18 meter per second. Alright, so this one we are going to use in any question where we will be given the answer in meter per second and the question is in kilometer per hour. So this is a really important concept that we are going to use in many questions. Every trick arises from the basic concepts only, so it's really important to remember the basic concepts also. Now, based upon the train type questions, there are only 6 cases that are possible depending upon the object motion and its length. Fine. So as you can see this table here, the object, if it's not moving and its length is negligible, then the time taken to cross the object is t equals to dt by st. Because the object's length is negligible means near about 0, and it's as its length is negligible, so therefore we haven't taken its distance. Okay, that is its length. Distance or length is same. Okay, now if the object is having some length, then we have added. In the second case, you can see that here for finding the time we have added dt, that is the distance of the train and the distance of the object, and then we have divided that by the speed of the train. For our convenience, I have denoted the distance of the train, that is the length of the train, as dt, and the speed of the train as st, and the distance or length of the object as do, and the speed of the object by so. Fine. So, and in the example you can see, for this example where the length of the object means, if the object is having some length like that of platform and bridge, then we will be adding that to the distance, means the total distance will be equal to distance of the train plus the distance of the object. Similarly, if the object is moving in same direction, then the speed of the object will be subtracted from the speed of the train. If it's moving in opposite direction, then the speed of the object will be added to the speed of the train. Fine. And if it is having negligible length, then it's not added. See, if it's having some length, then that will be added to the distance, because we will be taking total distance by relative speed. Relative speed is that is the difference of the speed of train and the speed of the object if it is moving in same direction, and relative speed is equals to the sum of speed of train and the speed of object if it is moving in opposite direction. You can see the examples from this table, and from this table it's really clear that in which case which formula to use. Fine. Now using this we will be solving the questions in really easy manner applying some more easy or short tricks. So let us see how. Now, so see, here is a question from some basic concept, that is here it's using the concept of average speed. So see, the question is, a man covers 40 km of a journey at 8 km per hour and the remaining 30 km of the journey in 2 hours. Find his average speed for the whole journey. So average speed formula is total distance by total time, isn't it? We know the total distance is what? 40 km plus 30 km, so that is 70 km by total time. For the first case we don't know the total time, alright, but we know the distance and the speed. So and distance by speed is what? Time. So therefore time is 40 by 8 plus, for the second case we know that the time is 2 hours, so here plus 2. Alright, now this will be 70 by, this is 40 by 8, 5 plus 2, that is equals to 70 by 7, that is how much? Now 70 by 7, that is 10 km per hour. So this is the average speed. Now let us see how to solve this question. A student walks from his house at 5 km per hour and reaches his school 10 minutes late. If his speed had been 6 km per hour, then he would have reached 15 minutes early. Now the distance from his house is, so we need to find the distance from his house. Okay. Now according to the details or data given, we know that the boy is walking from his house to his school. Alright. Now when his speed is 5 km per hour, he reaches 10 minutes late. And when his speed is 6 km per hour, then he reaches 15 minutes early. Alright. Now in this question, D is constant. Alright. So here S1 by S2 is equals to T2 by T1. Alright. Now we know that S1 is how much? 5 and S2 is 6. Now we will see the difference between these two. The difference between these two is what? 1. Now let me take this as 1 R. Okay. This is an arbitrary constant R. Now this difference, that is 1 R, is equals to the time difference. Okay. Now what is the time difference? See, 1 R is equals to, time difference is, here he is 10 minutes late and 15 minutes early. Whenever there is a combination of late and early, then for finding the time gap, we are going to add this two. Okay. That is 10 plus 15. So this is 25 minutes. Now we know that the speed is given in kilometer per hour. So we will convert this minutes into hour. So for doing that, we will divide 60. So 25 by 60 hour, as 1 minute equals to 1 by 60 hours. Now from this we can calculate T1. Okay. So T1 is equals to how much? 6. Okay, so this is 6 into R. 6 R. That is equals to 6 into 25 by 60. Alright. Next, we need to find the distance from his house to the school. So that distance is equals to S1 into T1. Whether you do S1 into T1 or S2 into T2, that will give the same distance. Alright, that is the same answer. So S1 into T1 is equals to, S1 is how much? 5. See, S1 is 5. So this is 5 into T1 is how much? We calculated this. This is what? This much R. And this 5 is 5 km per hour. So the unit is same. Whenever you calculate, you need to keep in mind that the unit is same. Alright. Now see, this is 30 and this is 60. So this is 2. Now 25 by 2 is 12.5. This is kilometer. So we got the distance. Alright. Now this particular question, now from this particular question, three questions can be asked. Okay, like first, in the first bit it was asked that what is the distance from his house. Okay, next the question that can be asked is what is the exact or the correct time in which he will reach his home. So if this one is asked, then to find the exact or the correct time, okay, in which he will reach his home, to find this, what we will do, let us see. Now see, from this particular question, three questions can be asked. Okay, in the first bit it was asked that what is the distance from his house. Second bit that can be asked in the exam is what is the correct or the exact time in which he will reach his home. So for finding that, let me represent the exact time or the correct time by ET. Fine, then we will subtract that 10 minutes late, okay, that 10 minutes from T1 to get the exact time. Why? Because in the first case he was 10 minutes late, so whenever someone is late, then we are going to subtract that time from T1. Okay, and in case 2, for finding the exact time, if we are using T2, alright, then we will add that 15 minutes, because he is 15 minutes early. So whenever he is early, then to find the exact time we will add that time. Okay, and whenever he is late, then to find the exact time we will subtract that late time. Okay, so from here we got T1 was 25 into 6 minutes, isn't it, minus 10 minutes. We had divided 60 to make it hour, but let me keep this in minutes to get some convenient answer. So this is 6, 5, 30 and 150. 150 minus 10, that is 140 minutes. Alright, this is 140 minutes. Next, if you are using T2, then you can add that 15 minutes to get the exact time. Alright. Now next question, that is the third bit that can be asked from this question, is what should be the speed to reach at the exact time. Alright, so speed equals to distance by time. We know the exact distance, alright, that is 12.5 kilometer, and we know the exact time, that is 140 minutes. Convert this into hour, that is divide 60. So this is this much hour. Alright, so now on cancellation, this is 7, this is 3 is 37.5 by 7, which gives 5.35 kilometer per hour. Alright. Now for above type of questions, for finding the time gap, we will add if it is early and late. Okay, we will subtract if it is late, and we will subtract if it is early. Okay, now let us see one more example from this case. If a train runs at 40 km per hour, then it reaches its destination late by 11 minutes. But if it runs at 50 km per hour, then it's late by 5 minutes only. Now the correct time in minutes for the train to complete the journey is, so here also d is constant. Alright, and we know that s equals to d by t. When d is constant, that time s1 by s2 is equals to t2 by t1. Okay, because we can see that this is inverse proportionality. Okay, so now from this we know the speed. Okay, so therefore t2 by t1 is equals to s1 by s2, that is equals to s1 is 40 and this one is 50. So see, now the difference is 1 and let it be 1 hour. Fine. Now this 1 hour is equals to the time gap. Okay, now here it's given that it's late by 11 minutes, means 11 minutes late, and 5 minutes late, means both are late. And I said you that when both are late, that time we subtract them. So 11 minus 5 is 6. Okay, so 1 hour is equals to 6 minutes. Alright, so now we can find T1. T1 is how much? This is 5 hour. Okay, 5 hour, that is equals to 5 into ratio is 6, so that is 30 minutes. Alright, now we have to find the exact time. Okay, now to find the exact time, ET is equals to T1 minus, it's late by 11 minutes. Okay, so this is 30 minus 11, that is how much? 19 minutes. So this is the correct answer. Okay, this is the exact time. Alright, see this question, how to solve this. Two trains started at 7 a.m. from the same point, and the first train traveled north at a speed of 80 km per hour, and the second train traveled south at a speed of 100 km per hour. Then the time at which they were 540 km apart is how much am? So according to the question, here they both started from same point at same time, that is 7 a.m. Okay, started at 7 a.m. from the same point. One traveled north, okay, with the speed of 80 km per hour, kmph. It can also be written as kmph. Alright, and another train traveled with the speed of 100 km per hour. Fine. Now we are asked to find the time at which they were this much apart. So distance is given as 540 km. We know the relative speed. So relative speed will be the sum of 180 because they are traveling in opposite direction. Okay, so this is 100 plus 80 kmph. So now time is equals to 540 by 180. Okay, so this is 3. Now this is equals to 3 hours. They started at 7 a.m. so the exact time is 7 plus 3 hours. So how much? That is 10 a.m. Alright, so the answer is here, this will be 10. Alright.